Hi, Assalamualaikum. My name is Nazrazib Benjani. My matrix number is J21A1043. I will represent my group, which is Group 5, for the calculus mini project. So, for the question 1, Ahmad made a rectangular block for his final year project, which has a dimension of 2 TCM by 3 TCM, and the volume is 1800 cm. So, for the question 1, we need to prove that the total surface area is A equal to 12 T power of 2 plus 3000 divided by T. So as we know, formula for volume for rectangular is width times length times height. So the width of rectangular is 2 TCM, width is 3 TCM, and the height is H. So let the height of the block be TCM hence. So the calculation is 2t times 3t times h equal to 1800, and 3t power of 2 h equal to 1800, and the h 1800 minus 1800 divided 60 power of 2. We will get the h. The height is 300 divided by t power of 2. So let the height of the block be TCM. So the calculation for the volume is 2T times 3T times H equal to 1800. So we get for the height is 300 divided by T power of 2. So to prove that the total surface area is A equal to 12 T power of 2 plus 3000 divided by T, area equal to 2 times 2t times h plus 2 times 3t times h. Area is 2 bracket 2t plus times h plus 2 bracket 3t times h plus 2 bracket 2t times 3t. So we get 4ht plus 6ht plus 2t power of 2, and where we get. So we need to substitute H, which is H equal to 3000 divided by T power of 2. So the area we will get A equal to 10 bracket 100 divided by T power of 2. T plus 12 T power of 2, we will get 3000 divided by T plus 12 T power of 2. So the surface area is A equal to 12 T power of 2 plus 3000 divided by T. So we already proved that the total surface area. So for the second question, we need to find the value of T when AH has a stationary value. So dA over dt equal to 0, A equal to 3000 T power of negative 1 plus 12 T power of 2. So dA over dt equal to 3000 divided 3000 times negative 1 t power of negative 2 plus 24t equal to negative 3000 over t plus 12 t power of 2. So dA over dt is negative 3000 divided by t power of 2 plus 224t equal to 0. So after we calculate, we get 3000 over t power of 2 equal to 24t. So for the last, we get t equal to 5. So for the third question is we need to calculate the value of A and determine whether A is a maximum or a minimum. So A equal to 12t power of 2 plus 3000 divided by t. And t is 5 as we get on the second question. So we need to substitute the t. So a equal to 12 times 5 power of 2 plus 3000 divided by 5. And we get 900 cm power of 2. And we will make it derivative dA over dt equal to uh, uh, minus negative 3000 t power of negative 2 plus 24t. And we will get 24 plus 6000 divided by uh, t power of 3. When t is 5, we need to exchange it. D power of 2a over dt power of 2 equal to 24 plus 6000 over 5 power of 3 is bigger than 0. So the a is a minimum when t is 5. So next, for the question 2, Mega Holding manufactures a cylindrical bologna sauce can with a volume of 250 cm. The cost of material for the two circular end and material for the side is Rm 0.008 cm and Rm 0.0015 respectively. So for the first question, we need to show the function for the cost of material of a cylindrical bologna sauce can. It equals Rm 0.008 over cm square to produce the circular end and Rm 0.0015 cm square for the side material. So H is for the height and the cost for the formula is cost equal to 0.008 times 2 pi r power of 2 plus 0.0015 times H bracket 2 pi r. So for the volume is for the volume of the cylinder is pi r power of 2 H equal to 250 cm cube. So H for the height is 250 divided by pi r power of 2. So for the function C equal to 0.008 times 2 pi r power of 2 plus 0015 times H bracket 2 pi r power of 2. And then we need to substitute the H and we will get C 0.0016 pi r power of 2 plus 0.75 divided by r. So that is the function of for the first question. So for the second question, we need to find the sizing that can minimize the cost of material for the bolognese sauce can. So C times R, we will get 0.016 pi r power of 2 plus 0.75 divided by r, where r is bigger than 0. C prime times r, we get 0.0032 pi r minus 0.75 divided by r power of 2. And then we will get, we will get 0.0032 pi r cube equal to 0.75. And for the r power of 3, we need to divide the 0.75 divided by 0.0032 pi. And then we will get r equal to 4.21 cm. So we need to do the second derivative to get the which this. So we need to do for So we need to do a second derivative to see if uh, the this is the minimum or maximum point. So as we'll get after substitute C uh, bracket 4.21, which is we get from radius equal to 0.032 pi plus 1.5 divided by 4.21 power of 3 is bigger than 0. So the second derivative is positive, so the critical value indicates a minimum point. So we get for the height is h equal to 0, 100, and for the height is we get h equal to 250 divided by pi times 4.21 power of 2, we will get 4.49 cm. So the production cost will be minimized if the can has a radius of 4.21 cm and the height of 4.49 cm. So for the third question, we need to sketch the graph of cos Rm versus. So for the third question, we need to sketch the graph of cos Rm versus radius of cylindrical brownie sauce can and show. So for the third question, we need to sketch the graph of cos Rm. This is radius of cylindrical brownie sauce can and show the minimum point. So for the y is cos in Rm, and uh, for the x is radius in cm. So as the graph show, we get the minimum point is 4.21 for the radius and 0.2673 for the cos. Okay, next, we will need to calculate the minimum cost. So cost, so the so next we need to calculate the minimum cost. So the calculation is same as we do on the question 2 for the radius, to get the radius. And but then we need to substitute the radius on the cost calculation by cos equal to 0.008 times 2 pi r power of 2 plus 0.0015 times h bracket 2 pi r power of 2. So we need to substitute the height and for the radius. So after we substitute, we will get 0.267238 for the minimum cost per can. So the answer, we already make it in six decimal places because some manufacturer may be interested in carrying precious of the calculation. So for the question 3, Ramesh worked as a designer in ABC company, which produced the miniature bowling pins (MBP), as shown in Figure 1. As part of the height design, he need to compute the volume of MBP, which is made by rotating the function. The function is f x equal to 1 over 5 square root negative 6 x power of 6 plus 10 x power of 4 minus 5 x power of 2 plus 1 on the interval 0, 1 along x-axis. So for the first question, we need to sketch the graph for the function of value MBP. So this is the graph that we already sketched. Y over x. So next question is we need to calculate the volume of MBP. So integral R L E bracket x dx equal to interval 10 pi bracket 1 over 5 square root negative 6x power of 6 plus 10x power of 4 minus 5x power of 2 plus 1 power of 2 dx. So after the calculation, we will get 2 over 105 pi. So